So in this video, we're going to be dealing with functions. So functions are going to be extremely important in all of mathematics, really. Most of it, at least. When you start learning calculus, you're going to see how functions. You're going to start studying functions really deeply. You're going to look at local maximum, local minimums, absolute maximums, absolute minimums, continuity. You're going to look at all these interesting ideas when it comes to functions. And here in this video, we're just going to be introducing what a function is. Hopefully this video can just start your thinking, just hopefully get you thinking about what a function is, and over time when you deal with functions, it's going to become a lot more clear to you. And that's true with all of mathematics, or most of it at least. Very hard concepts, or at least very elementary concepts that you might not recognize immediately. Over time it's going to become solidified in your mind, and you're going to build connections that hopefully eventually you will understand. So if you're deliberate enough to try to learn it. So let's go to what a function is. So a function is a relationship between inputs and outputs. What people usually use as examples to try to understand or explain what a function is a machine. So if we were to have a machine, so some kind of a machine here. All right, so here's some kind of a machine, and this machine. So let me just say it's a machine. This machine, say it has inputs coming in, so it has some inputs coming in, and then some processes occur here. So some processes occur. Some processes occur. Some process, okay? Some process occurs, and then there's outputs that come out. So you have some inputs and you get some outputs. Typically in a function, the inputs are going to be the x values, and the outputs are going to be either the y values or the f of x values. We'll just say the y values for now. So the inputs, so input, output, and after there's going to be some in between. There's going to be some processing, some crunching, or something that's going on here. Now let's talk about an example function. So let's say that we had f of x, and this is typically the notation you have for a function. We use f typically, but it can also be like something like g of x, but I'm going to use f of x because f for function, so f of x, what it essentially says is here we have an input, and this whole thing, whatever you input and then you crunch and then you get an output, that output is this f of x value. Okay, so let me show you to make this a little bit more concrete. Say f of x is equal to 2x plus 3. You've probably seen you've seen expressions like this before when dealing with equations. So essentially, here you have a function. What I want to do is I want to input a value in for x, right? Everywhere I see an x, I'm going to input a value, and then what's going to happen is going to be quite interesting. So if I input 1, for example, f of 1, this is going to be equal to 2 times 1 plus 3. Notice that there's some processes that are going to occur to this one that are going to change this one. It doesn't necessarily have to change it. Like if we have a function like f of x equals x, for example, right? This is not going to change our value in any way, so the output is going to be equal to the input in this case. The machine is really not doing anything. But in this case, the 1 is going to be changed. It's going to be multiplied by 2 and then added by 3. So f of 1 turns out equaling 2 plus 3, which is 5. 2 plus 3 is 5. So the output here, in this case, the output ends up being 5. And the machine, what it did was it added, or it multiplied by 2, the input, and then it added by 3. So whatever input you put into this machine, into this function, it's going to output a number that is multiplied by 2. From the input's going to be multiplied by 2, added by 3. That's the specialty of a function. So this is the solution here. Let me input another number. Let's say we inputted like 5, for example. You can input anything, right? 2 times 5 plus 3. You can input any number here, and it's going to be 10 plus 3, which is 13. So this is f of 5. So you can input any real number here, and it should work out, and it worked out here. So that's what you have. So that's a function, right? You have an input, and that's the x value, and you have an output. It doesn't have to be the x value. You can have functions defined actually in another way. Like for example, you can have functions defined like this: g of y is equal to So the input is y here, and the input is y, and then we're going to have an output, which is going to be the x terms, right? So this is also something that you can have, and in this case, you would have an input of y and an output. And actually, this is not x. This is supposed to be y plus 4, or something like this. This is, in this case, what you have here is the inputs are actually y terms, and the outputs are x terms. This is a different kind of a function that you will be seeing later on, but in this case, you're inputting the y value, and then you're getting out the x value. But in this case, we're not going to worry about that. This is something else. This is a topic for another video. It's a topic for another video. But in this case, essentially, you have an input into the machine, and that machine produces an output. Now, there's other things that you need to see. Each input, and this is going to be important, each input has, I should spell input correctly, each input has exactly one output. Exactly one output. This is a rule. So basically, if you think about the machine analogy, each input, each thing that you're going to input into the machine, it's going to change it in a certain way, and it's going to only produce one output because it's going to change it in that same way. The process that's going to occur each and every time is going to be the same process. So it's not even possible that an input is going to produce a different output, because the same process is going to occur to that input, so it's going to be only one output, so one kind of an output. So if we were to think about this a little bit more, you can say that this is accurate. So some questions, like if you would look at books or something like that, they ask you if this is a function. I'm just going to draw it here. Say if we had like this, we have this curve looking thing. Say it's a function defined. Input is x, right? So defined f of x. So if this is a function here, in this case, inputs would be the x values, right? The inputs would be the x values, and the outputs would be the y values. So if we look at any x value on this line, it's going to always produce just one output. Say, like, for example, this value right here, this x value. If we go up, we see that this is our output. That's only one value, so it's one output. That works. And if you actually see, if you can draw the line that I just drew like this to every single x value, you can just draw a bunch of lines, right? And if it goes through the function only once, that means we have only one output. And this is something that we call the vertical line test. So if we think about taking a line, I'm going to do this in red, and we kind of go through the whole function, then we'll see, and this function goes on forever on both sides, we'll see that at each point, we're only going to have, this line is going to go through only one point of the function at each x value. So this is the vertical line test. Vertical line test. There's other tests like the horizontal line test as well, that do exist, but here, for this function, for the understanding of what a function is, this is the vertical line test. And the vertical line test, essentially, it tells you if it's a function or not. Let me give you an example of something that wouldn't be a function. So if we have like a circle, for example, right? This is not an example of a function here. If we were to think about this, this wouldn't be a properly defined function in the definition of what a function is, because here each x value, so if we look at not every x value, of course the x values that are part of the domain of the circle, then we see that from this point here to this point here, basically the endpoint of the circle, so at this point from this point, we have these x values producing two separate f of x values. That's not possible. So when you look at when you look at the function being defined in this way, this is not a function when we look at it in this way. So in this case, this does not pass the vertical line test. So does not pass the vertical line test, VLT, vertical line test. So not a function defined in this way. So this is what we can say here. So the other thing that I wanted to point out is, this is just a side note. Is multiple outputs, or multiple inputs rather. Multiple inputs can have the same output. What do I mean by this? Let's read it again. Multiple inputs can have the same output. That means, for example, if you see here, right, in this function, which is defined to be a function, we see here that if we look at this x value right here, this one right here, and if we look at this one right here, it produces the same f of x value. So this is like, for example, 2, right? This is 2, for example. Both of them produce 2 as an output. So since both of them produce 2 as an output, this doesn't affect the fact that this is still a function. It can be the case that multiple x values produce the same f of x value, and that's fine. So basically, multiple inputs can produce the same output. That's fine, because those x values, when processed with the machine, can yield the same result, and that's completely fine. So yeah, that's essentially what we're going to think about when we're dealing with functions. There's so much about functions. There's so much to learn about them, because they're very, very interesting. You'll be working with them a lot over the course of your mathematical journey. So I hope you found this video helpful.